Hello everyone, welcome back to the channel. This is Seaport Overview Part 2, and I think it's the last part. And in case you missed Part 1, essentially what we're trying to do is we're trying to make a query to essentially query Seaport data, right? So Seaport is the contract that runs, that Opensea runs on, so it's called Seaport. And if you've not checked out part 1, highly recommend it, because in part 1 I sort of go through how you would handle one main use case, and in this video I would like to cover the remaining 2 use cases essentially. So as I was going through the query, I thought it would be easier to explain if I have some sort of visual, and so I created this visual here on Canva to sort of explain how it all ties together. So on Seaport there are 2 types of transactions. You have your regular transactions, which is why I'm calling it as without orders match. So an example of this would be I'll have to take this example here. Let's see. So this is an example where if I go to event log, I only see the order fulfilled event, and I don't see any orders matched event. Okay, so that's what I'm calling the without orders match event. And then on the other hand, there are also transactions where there is an orders match event, and an example will be this. So in this case, you can see an orders match event over here. So those are the 2 types of transactions on Seaport. And so for events or for transactions where there are no orders match, right, you can just refer to the order fulfilled event. This one, right? Etherscan has a great feature now where you click on ABI, it sort of decodes it for you. But essentially, this is what you look at, right? And the 2 big parts, or the 2 main data parts in a Seaport event, is the offer and also the consideration, right? So you can just base off of these 2, like, offer meaning what is the person offering, like if the person is offering NFT, it will be an offer, and then consideration will be what would the person like to receive in exchange for what they're offering. So if they're offering an NFT, they would typically expect to receive some sort of payment in currencies, right? So whether it's ETH or ERC20. Small caveat here, it's possible to exchange NFTs. So offer can be an NFT, and then your consideration can be an NFT as well, but that's very rare. And so I'll just cover the main use cases, which is buying and selling NFTs using currencies instead of other NFTs. Okay, so I was saying without orders match, there's only one order fulfilled event being emitted, and you can use this event itself to get all the information you want, right? For example, offer could be the NFT, and then consideration could be the how much in exchange in ETH or WEF, right? The other situation can be true as well. Like offer can be someone giving an offer to an NFT, so that can be the offer, and then consideration would be the NFT itself, right? So those are the 2 cases for this category. And then when you come to the with orders match event, right, in the presence of orders match, which is something like this, where you see there's order fulfilled, and then suddenly there's an orders match. Essentially what Seaport is doing is it is matching 2 separate orders, and so you would have to deal with multiple order fulfilled events. In which case you would handle things differently. Like for example, in this case, there are a lot of edge cases, but I think the easiest approach here to get the data is just take the offer from each event, right? For example, this event here right here, the offer is item type 1, which we learned from the previous video. Item type 1 is an ERC720, ERC20. Right, this is the WEF contract address. And then the other order if a fulfilled event, the offer is item type 2. And item type 2 is an ERC721. Right. I also have this cheat sheet here where it tells you the common item types. So 0 is native, E1 is ERC20, 2 is ERC721, and 3 is ERC1155. So that's the difference. So I think in the first part we sort of went through this, right? We sort of went through the situation where the offer is an NFT and someone wants to buy the NFT, right? You can sort of do the same for accepting an offer, right? It's just the offer will be currency instead of NFT. So you can, sort of just change the logic a little to get that query. I think what I'll focus on today is really this one, where in the presence of a orders match, how do you extract the data, right? And also in the same transaction itself, there can be multiple sale events with and without the orders match event, right? So for example, I don't have an example here, but you can imagine, so right now these two order fulfill events, right, sort of belong to this orders match event, but you can imagine there could be another order fulfill here, and this is like a standalone sale event. So that can happen, and so in those scenarios, how do you sort of ensure that when you're joining these two events, you are essentially joining only on where it actually is, and not like disregarding other sale events. So I did this differently in the actual model itself, but I think there is another approach that I can take, and that approach is first get all the order fulfilled events from the transaction, right, and then extract the orders match event and sort of left join the orders match order hashes back onto the order fulfill, so we can sort of tag them, right? So let's see how that works in real life. Let's see how that works. What do I want to do here? Okay, so I think I want this transaction. So all of this code is basically the same exact code as in part 1. I'm just forking the data, and then I want 7FE. So okay, so this is what I want, and let's just select from raw. Let's just call this as like fulfilled by offer final, right? So we don't disturb that logic, and I just want to see what is in my raw CTE where it is the orders match event. So I should be getting three events here. Might wanna March 29, 2025. Okay, let's change this. March 29. Okay. So I have 3 things. The 2 order fulfilled events as expected, and also an orders matched event name. Now, first thing that you will notice is that the order hashes are not quite what you see on Etherscan. So if you go to order hashes, this is in bytes 32, and here is in some sort of jumbled up stuff. So in this case, I would use event logs rather than decoded, because clearly something is wrong here with the decoded table. So I would use event logs, and let's just try to make a new CTE. So raw events from, let me just copy this raw table. So from flag event logs, and then transaction hash my order hash, and because I only want this to be the orders match, I'm gonna say the topic 0 is orders match, and topic 0, oops, goes this orders match. Okay, cool. So now we can sort of let's run something like this: transaction hash, event index, what is it? Data. Okay, data. And because we're dealing with data, we need to substring it. So got my handy substring. I think that is it. Yeah, let's run this query. Okay, so let's see what data is being emitted. So I copy this whole thing, go to JSON viewer, paste it, and we would see, so what we're doing is we paste our usual function where we split the data into 64 characters long, because data is packed in sizes of 32 bytes, so 32 bytes means 64 characters long. And we see here some what's it called? What do you call this? Offsets. There you have it. Offsets. And the first offset would be the I guess offset, right? So 20 hex to in, you can convert this from hex to in, but I know it's 32. There you go, 32 divided by 32 is 1, so skip 1, and the next one will tell you how many elements are there in the array. This converted from hex to in is 2, so then the next two hashes, the next two 32 bytes are the orders, the what's it called? The order hashes, right? So I'm going to do a shortcut here, but in your actual query, or if you look at the model itself, this orders hash can be more than 2. It can be 4, 3, right, so on and so forth. So how do you cater for that? I think that requires a lot more logic, and so I'm just going to show you how to cater for the situation when the order hashes are 2, which is the more common case, right? So just a big caveat that whatever I'm doing right here is just for this specific case where there are only 2 order hashes. In reality, there can be more than 2. There can be even number, odd number, right, of orders being matched together. Okay, so let's ignore that and let's just take 2 and 3. So I'm gonna say order hashes as select from raw events, and then I'm going to need my transaction hash, event index, and I'm going to need this and this. So how do I do this? Try and think, how can I flatten them? Data part. So the extract 2 will be this, right? 2, but this is you won't be able to get very accurate results with this. So maybe the scalable way would be the scalable way would be something like where you would have to flatten part, I guess. Yeah, that might be the only way. Okay, that's fine. Let's just do it. So part 1, and let's try to convert this hex to int of part 1 as number of elements, right? And then my order hashes raw would then be part lateral flatten part, right? Where index between we want this first one, which is index 2, and because we know the number of elements, it will be 2 plus the number of elements, which is num elements, minus 1, right? Because it's 2, and this will be the set. Like if this is 3, for example, this will be between 2 and oh wait, that doesn't work. It's supposed to be like this, right? Yeah. If this is 2, for example, so this will be between 2 and 2 plus 2 minus 1, so it's 3. So between 2 and 3 would be these 2 hashes. If there are 3 hashes, this will be between 2 and 2 plus 3 minus 1, which will be 4. So it will be 2, 3, 4. So this logic works out. And because 2 minus 1 is 1, you can just put 1 plus num elements, so that's fine as well. But I'm going to keep it like this, and I'm going to say this is my value, which is my order hash. Yeah, so let's query this and see what we get. So what we did is we just flattened the part, and the part contains the order hashes, and we're filtering for when we're essentially filtering for indexes where it is an order hash, which should be 2 plus however many elements there are. In this case it is 2, so it is this query here. So yeah, there you have it, right? So we have transaction hash, event index, and an order hash, and we can confirm that this is the same as this, right? Amazing. And one more thing we want to confirm, let's first copy this here, right? So we can compare them. Now let's query raw events. Let's query raw. Yeah, raw. Select all from raw, because we want to see if the order hash from the regular sales have the same order hash in the decoder event logs. So you can see here order hash is this, and this matches exactly with this, but this has an extra 0x, so we would need to add 0x in our order hash. Okay, so I would just do something like this, right? Concatenate 0x to value, and that gives me the order hash with the 0x in the front. Okay, I think that solves our issue. Yeah, I think that's good. Okay, so now we need raw, right? We need to know now. We need to know like which order fulfilled events belong to the order match type. And so how we would do that is we would join this order hash that's available in order fulfilled to the order hash that we just got, right, from this order hash raw. And I think this would just be a like a direct straightforward join, but I do need to pull out the order hashes column first. So let me check the raw table. Do I pull it out? Okay, I did pull it out in raw. So I do have an order hash column here. Now I'm seeing this now. And so I can actually run a query to join it right away. So select from raw. First, let me filter where topic 0 is the order fulfilled. So did I filter for topic 0? Oh, I did not. Okay. So I need to add this topic 0. And topic 0 is this. Or you can also add where event name is order fulfilled, right? Same thing here. Okay, so now that ensures that when I pull raw, it pulls the order fulfilled. And then I'm going to say from raw, I want I want everything, I think. Do I have event index? I do. So I want everything from raw, and when you left join order hashes, join it on transaction hash, event index, and order hash. Right. So this is ensuring that any event within a transaction, as long as its order hash matches exactly what the orders match event order hashes are, then I'm sort of tagging them and saying, hey, these are the actual, these are the events where we need to apply this logic, right, instead of this logic. So that's what I'm doing here. Alright, let's run the query, see what we get. Not sure how long this will take. No data displayed. That means something along our join is wrong, whether it is the transaction hash, event index, or the hash. So to debug this, first I would just select from raw, or rather select from order hashes and see what we get. So transaction hash, event index 108, and then order hash is this. Okay, everything looks good. Now I am going to select from raw and then see what comes up. Order hash is this as well. Transaction hash looks good, event index looks good. Order hash might be not good. Let's see why. Transaction hash, event index, order hash. Let's try left join and see what's causing the issue. Orders match tag. Oops. So usually if there's no data shown earlier there, or if this is null, oh hang on, oh this is type. Okay, so that means one of the stuff is not matching. Let's see, this is 7F, event index 107, 106. Oh, okay, I found out the issue. I shouldn't be joining an event index because the event indexes for order fulfilled are 106 and 107, and then orders match is actually 108. So I should just be joining on transaction hash and order hash, not event index. So remove this, and I think I can just remove this as well. Yeah, and then run the query again and see if we are able to join it correctly again. Okay, there you go. The type column has entries which means our join is successful. And yeah, so essentially it tells me that this transaction is an order hash transaction. So we can actually test that by including another transaction. So let's include this transaction, right? Yeah, this one over here, where it is there's only an order fulfilled. The date is April 11th. This is 17. Oh, this one. Date in April 11. April 11. Yeah, I think that's it. Copy this, go to my raw table, and paste this. Perfect. Okay. So if I run the query, I should get 3 rows. 2 rows belonging to one transaction, and then the other row belonging to the other transaction. So 2 rows belonging to the orders match transaction, and then 1 row belonging to the direct ETH buying transaction. So we'll let that run, and then meanwhile I'll see if, okay, there you go. So 3 rows as what we expected. 2 rows where it says order match tag. Okay, there you go. Yeah, I think that's pretty much it. So now we can sort of categorize or sort of use custom logic to decode things correctly, right? So for example, we can say if the type is null, then go through this flow where the fulfilled by is, try to figure out this flow, right? Basically what we covered in part 1. But if the type is not null, then we would sort of now apply this logic, right, where we take the offer from each event. So let's do that. Right, so maybe I should spell out everything here. So transaction hash, index, order hash, event name equal to log, offer, recipient, for item type. Wait, what? Okay, sure. Event type, event index, got it, and then type. Okay, so now this would be my base with OM tags, OM being orders match. So now I can go ahead and say something like OM sales, right? OM transactions, which is order match transactions, right? Order match transactions as, so order match transactions, first I want to get where it is of item type is 1, which would be the 1 would be 0 and 1 would be the currency, right? So let's just call this as like currency as select from this where offer item type equal in 0 1, right? So again 0 1, if you refer to the cheat sheet, 0 1 is 0 is native, 1 is ERC20. So that helps you differentiate that we're looking only at the money portion of the sale, right? And the reason, again, the reason why we have to do this is because in the transactions where there is an order match, there are multiple order fulfilled events referring to the same NFT sale. So we need to pick the offer part only from both events and sort of combine them together. Which reminds me, I need a way to sort of join these two things together. So maybe I can say how do I join these two together? I can always just take the first element and combine it with transaction hash, right? So how do I do that? Orders match. Yeah, this is flattened, so I can just say part 2, right? So concat, I'll just do this transaction hash, part 2 string s tx order match identifier. Okay. Okay, so why do we do this? So let's see what the effect is. Oh, okay, so error line 1 in unexpected something. So that means there is something wrong with what I just did. Order mesh unexpected. Oh, okay, there you go. So this needs another this. Okay, that should be good. So let's run this query. I added a new column called transaction order match identifier, and we would see that this transaction, these two rows where it belongs to the same transaction, and it belongs to the same group of order hash, right? These two are linked to the order hash event, even though their order hash is different. I assign them this identifier, right, where I just take the transaction hash, concatenate it with the order hash, the first order hash. So now these both, this column for the both of these rows are the same, and so I can then join the two together, and they'll come in handy in a bit. So let's just first finish this. So I've got my currency portion, and I want no, first I need to see what is it. I forgot. But I'm pretty sure I need the transaction hash, I need the order match identifier, right? I need the code log. So we filter for 01, which means native. So the decoder log, let's take offer. So offer would be, I mean, we need to flatten more, but in this case, I'll just take the first element in offer. So it'll be offer amount, right? So offer 0 amount as total price, right? And same thing, decoder log offer 0 identifier. Let's copy this thing. Item type and then token. So item type is, we already know the item type, so we just need the other two. So identifier, and this will be token. So identifier, if it's currency, right? 0 and 1 are currencies. Identifier is useless, so we can just ignore that. But if item type is 4, item type is 3, which is ERC 1155, identifier is, item type is NFP, so item type is 2 and 3. Identifier is the token ID, so we want that if this is NFTs, but it is not, so I'll just discard it. And then token here would be the currency address. I think that's it, right? So we have transaction hash, identifier, what is the total price, and what is the token address, currency address, I mean. And then what else we need? Offerer maybe. So offerer would be, did we write offerer in, okay, offerer. So if the offer is total price, doesn't that mean the offerer would be the buyer, right? Because they're offering some amount of money. So they should be the buyer address. So let's confirm that, right? So this transaction is 7FE, which is this one, and the offerer is 917. So let's look at 917. There you go. So the this 917 address receives the NFT. That means they bought the NFT and they offered their amount, which is Rev Ether, which is the contract address that we saw over here. So offerer in this case is buyer address. Simple as that. And then recipient is 5E05. Now recipient is a bit tricky, so I would just not take recipient from here and just take recipient from the other offer, right? So which is what we'll get to in a bit. So we're done with currency. Now let's do NFT. So same thing, I'm just going to copy an item type in 2 and 3. Okay. Comment this all out. Call this as NFT and run the query, and let's see what data we get. But I'm really expecting that we need this information. Oh, what is this? Why is this showing up? Base with oh, okay. I forgot to filter where this is not now. Because if it's not now, it means it has an order match event, which we want for this case. But if it does not have an order match event, then we'll go through the regular logic right over here. Okay, I think that's it. Okay, so what else? So NFT would be, again, look at the offer. So offer 0 amount is the number of NFTs, which again would make sense if it's a currency, but for NFTs doesn't really matter if it's ERC721. But we would put it as quantity of NFTs. Token would be the NFT address. Item type we already know, so we can remove that. And then identifier is the token ID, right? So token ID 2038. Item type 2 means it's a 721, and then token would be a NFT address. So I think that's it, right? So we can just call this as like if offer item type 2 is 2 ERC721, else ERC1155 as NFT standard. Perfect. Okay. So now let's run this query and see if we manage to pull out the data correctly. And if we did, the next step would then be joining the NFT portion with the currency portion, right? So let's see, identifier, buyer address, quantity of NFT 1, NFT address 916.2003.721. Okay, so I noticed something. Buyer address is not what we want, because the offer here is the NFT, so the offerer will be the seller address, because the seller owns the NFT and they are offering up their NFT to be bought or sold, right? So yeah. So let's do the final OM, which is orders match. And the orders match would be selecting from this inner join this using transaction hash and also TX order match. What we want the seller address, we want the buyer address, we want the total price, currency address, oops. We want the NFT address, token ID, quantity of entities, entity standard, sure. I think that's it. So let's run the query and see if we manage to join the two things together. Now, a common mistake I see is that people just filter for all possible order events, order fulfilled. So they will say, okay, order fulfilled, this one, that means this is the amount, right? And then sort of sum all of the order fulfilled amounts, right? Which is wrong. Right, because in this case, there's an order match again, and you have to go through this logic over here. Oops. There you go. Okay, so it looks like we managed to join them together in one row, and we have the seller address, which we can verify. Seller address is indeed 5E05, and the buyer is 9176. So 9176. Total price is 185, bunch of zeros. 185, a bunch of zeros. So you can add this number to this number, and you get 185. And currency address is web, NFT address is this, right, so on and so forth. Okay, I guess your next question would be then, how do you get the platform fees and any royalty fees if possible? Well, in that case, you would have to look into consideration for both of these, right? And from there, then you can then extract the consideration. But you will still use the same logic of having this identifier to be able to join the two together to make it into one row, right? But yeah, I think that's it for this video, right? Essentially, we covered how you can decode, or not decode, but how you can make, how do you write a logic such that it takes the Seaport events for this route correctly, instead of just a blanket statement to take all these order fulfilled events. I think that's all from me. This is a long video, but thank you so much for those who are listening to the end. Leave a comment down below if you are still listening, so that way I know. And what else? All the query links will be in the description. And yeah, thanks again for watching, and I'll see you all next week. Bye.